In the last set of problems, the whole idea was basically just understanding whether or not things are proportional. And what makes the set of 4 problems that you're now looking at different is you have variables. And even, one in the denominator. So on these instructions it says solve a proportion, so we're going to be finding a missing value. And in solving each proportion, it might be necessary that you round to the nearest hundredth. Some problems might say the tenth, and so on. But either way, we'll jump into number 1. Using logic, too, it's kind of nice to, think about, well, something can be multiplied, and 5 times 4 would give me 20. So what would I have to multiply by 4? That would also give me 4. So no matter what, if you understand how ratios work, that's a good thing to do to say, well, in the back of my head, I know that this should be 1. And if I know it should be 1, that gives me some bearings to kind of strengthen my understanding of this. Because if I use the new algebra concept of cross multiplying, then I bet it'll help me understand. So if this is your textbook problem and you rewrote it already, the rewritten part would be in black. And so we'd show that, these little lines, I'm not crossing out the equal sign. I'm showing that x is going to be multiplied by 20 and 4 times 5. And I always like to see 20 times x written with the number in front. So here's 20x equals 4 times 5. And here it actually is kind of nicer to multiply it out. Normally I encourage you to leave it as 4 times 5. So then when I go and I divide 20, I get x is 1. Now if we wanted to show our check, we could. Here's a fifth equaling 4/20. And then, I could get a common denominator by multiplying the top and bottom by 4. And 4/20 is 4/20. But a lot of times what you just think to yourself is, well, this value would be 1/5, and if I simplified this, it would be 1/5 as well. We'll make this a OYO problem. And if you're not sure you want it to be OYO yet, just go back and rewatch the first one again. I'm going to not explain the work, but I'm going to put all the work up in 5 seconds. I have multiplied 16n to get 15 and 24. And rather than multiplying 15 and 24 to get a large multi-digit number, I'm going to go ahead and divide by 16 in this step. So now I'm actually solving. And the reason I kind of like to avoid is because if I know that 24 over 16 simplifies to 3 over 2, that'll save me a good amount of work with having to multiply and reach for my calculator. Because now I can just say n is equal to 45 halves. And if you looked in the back of the textbook, it might say 22 and 5/10. I always discourage going to decimals, so we'll leave our answer as 45 halves. There's always a number of different ways you can kind of think about these. Well, this numerator isn't quite twice as big as 16. So whatever I have up here should probably be pretty shy of doubling 15. So I would say that this is bigger, which means things are pretty good, but not quite to 30. This one we'll do together, only because of the whole not simplifying right away. Not multiplying right away. So here I have 40y equals 8 times 25. Dividing both sides by 40, no problem there. And then I'll get y is equal to, well, looking at what I can simplify, 40 is 5 times bigger than 8, so I make sure I change that denominator to having a 5 up there. And then I can keep on simplifying, because 25 over 5 becomes 5. And it's important that you do that step by step, because otherwise you'll kind of muddy your picture to where you can't really tell what's going on. Now if I wanted to picture a 5 up here, I'll sneak a 5 in there. Maybe I'm just thinking about it this way. And if I multiply that by 5 and multiply that by 5, these would definitely form a proportion, which means that this equal sign would be true. And again, I'm just talking about all the different ways you can check these. This has decimals, not much of a big deal there. So we'll make this an OU and then I'll briefly talk about it. 5 seconds, the answer will be up. Now at this point, you actually could do some fancy footwork and like think, well, this could be 1.3 and that 1.6. Whoops. I'm not telling you to write this down, by the way. And then I could be like, well, here this 4 goes away, and there's, that could become 0.4. So that then if you felt like it, you're typing less in your calculator, but I think that that's probably overthinking it. So if you were trying to look ahead like that, that's awesome. But here I'm going to say it's probably just as easy to punch the whole thing into your calculator and just get 3.25. Looking back at the original problem, the denominator's a little bit bigger than the numerator, and 3 and 25/100ths would be a little bit bigger than 2.6. And since they gave us decimals, we'll leave it in decimals. We will not convert this back to like a improper fraction or anything like that. Before we head into the next set of problems, which would be word problems after these guys we just did, we'll stop here so that it keeps it a short and sweet video.